At the very beginning of the 1800s, the waters of physics were relatively quiet. In the depths, the sparks of electricity were getting ready, frizzling in order to floodlight the world. But at this time, people were only gathering knowledge. Instead, it was chemistry that brought results. Let's peek into a laboratory in 1808, where Gay-Lussac and Dalton are having a debate.
I notice that you still disagree with me. Let's look at the facts. There's some baking soda here. I'll put it into this cylinder. This is acetic acid. These are two different kinds of matter. I'll pour the acid on the soda. Some kind of foam and gas is created. That's a third matter. How come?
Obviously, you think of the matters, don't you? That every matter consists of tiny particles being so small and we are unable to see them.
It can be differently. This gas can be present everywhere in this cylinder, only if we imagine that the gas particles intrude in between air particles.
It is not a question to be debated, it is evident.
So I'll continue from this base. I found that if I make a third matter from two others, the rate of mass of this matter is important. For example, if we want to make water, we have to add 8 kilograms of oxygen to 1 kilogram of hydrogen. So one oxygen particle is 8 times heavier than one hydrogen particle.
This is a statement that I don't believe. Look, two different types of gas have emerged from the water. Examine their volume. One of them has twice the volume than the other. And let's see what matter they are. At first, the bigger quantity. This was the hydrogen because it burned up with a pop. And let's look at the other.
The glowing stick has flared up. Then it is the oxygen.
Remember, there was more hydrogen, so there is twice as much hydrogen in any given amount of water, but you said quite different rates. What is right?
I already know.
Avogadro! How come you are here?
It doesn't matter. The main thing is that I know the explanation. Particles of every matter are atoms. They are the same in a concrete matter. Atoms join together for molecules, which are particles of the more complex matters. The molecules are the same too in a given matter, but there are molecules consisting of a lot of atoms.
And who is right of two of us?
Well, actually both of you. If you take the equal volume gases under the same circumstances, they have exactly the same number of atoms. In the experiment of Louis, the volume of hydrogen was twice as much as oxygen. It means that the water molecules consist of 2 hydrogen and 1 oxygen particles.
And what about mass rate?
The oxygen particle is 16 times heavier than the hydrogen, so your numbers are also right.
Oh, it is all very interesting. Would you elaborate on this topic?
With great pleasure, of course.
The discovery of the bonding of particles brought satisfaction and further development into the world of science. But inside the matter, it caused panic. In order for us to witness the events, I'm going to do some magic, so we can see the thing's size of note, point note, 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 1 meter. Hocus pocus, abracadabra, let the window of the word burst open and let's see all the atomic specks.
I inaugurate the Atoms Anti-Crisis Conference. The minutes show 92 participants. Some elements of uranium are missing justified. They can only come later and for a short period of time. It's obvious to everyone that we are in a serious crisis, and we need to make a determining decision for our future. Man has turned out to be smarter than we thought, and he is knocking on the door of our secrets. Please, share your opinions with me.
I'm a little heavy, also in the way I understand things. And what is going on is all because they discovered our existence. Why is it such a big problem?
Because our private life is going to be over. People are going to want to know more and more about us. And if they have discovered our inner self, they will want to put it in their service.
This is nothing new, since they could not live without us before either.
Well, it is a bit different because they are still under our control. But we are also a bit guilty in that we have become recognizable. Let's take, for example, this hydrogen, who is really good for nothing. She has had relationships with so many others that it is no surprise if she can't keep a low profile. Or takes her chlorine or bromine. They spread the smell around themselves that they can be identified just about anywhere.
Let us not forget, though, that we are also approachable simply by way of thought. In the ancient times, Democritus did not experiment with us. Still, he said that the only truths are atoms and space. We even got our name from him.
But what kind of name is this? The word atom means undividable, but we are not undividable.
Is it you who is saying that? You are almost like that. Are you so proud of your 2 parts? Me, on the other hand, can be divided 80 or 275 parts. And let's not talk of further details.
This is exactly the topic of our meeting. We have to decide whether to let people discover our secrets. And if yes, to what extent?
Before this heated atmosphere would burst my persona into flames, let me express my opinion. I think it's unavoidable for us to concede, mostly because they have got too close. But if this is the case, let's use the opportunity. People need a good lesson. They think that they already know everything and they have processed all the theories. Let us confuse their thoughts a bit. I suggest making them unsure about the question of the conservation of energy. Then, let us steal some weight from our systems, and let's show the currency of our interatomic exchanges, the quantum. I guarantee that they will be occupied for a while.
I agree with colleague. Let's give food for thought of a couple of decades to the scientists. But I would call your attention to something. I am not sure if people are prepared to know about my secret. This energy within us could serve good or bad cause equally. We cannot know what they will use us for. And I suggest that this discovery should be the last step for them. And I would also stick to exclusively supporting the very best people to succeed in this field.
Are there any more opinions? So, I'm putting the question to vote. Who supports people in discovering the structure of the matter? The result is unanimous. I declare that the atomic age may begin.
And so it began. In the 4 golden years of physics, Röntgen discovered the X-ray, Becquerel found the alpha, beta, gamma beams, Thomson discovered the electron, and the Curies produced radium. The atom models were born after each other, especially after the nucleus had been identified by Rutherford.
Let's carry on with the story. After this, everything was centered around the nucleus for a while, not only the electrons. Partly because it was new, partly because some questions still remained unanswered. In 1932, Chadwick discovered the missing part of the nucleus, the neutron. The popularity of the neutron greatly surpassed what the nucleus got. This is why it is very special that the neutron is going to give an exclusive interview to the participants of the show. Please welcome the neutron and his mates. Everybody welcomes with great enthusiasm, but this wasn't always the case. Why was it so difficult to discover you?
Because I'm completely neutral. I neither attract nor repulse, at least in the electronic sense. Above that, no power can push me off my way, let it be magnetic or electronic.
Then, how did you get caught, so to say?
It is all because of my pride. Whoever came my way, I gave them a little push, and they noticed that I'm in the nitwits that got pushed.
You seem cheerful and healthy. Why?
My body weight is ideal, exactly the same as the protons. But I live a comfortable life with no stress. I'm also in the center, but I do not have to work, only occasionally. On the other hand, the proton does. All day long he needs to control and slow the electrons down. Some of them still got away.
How did Rutherford get a sense of your existence before all this?
Because the atomic number and mass number of nucleus did not correspond.
I don't understand this.
Oh, I thought you wouldn't.
But
please don't tell me that your field of interest is in the humanities, because I will transform into a proton right away. We will help you get this. Let's look at the nucleus of hydrogen. It is constituted of one sole proton. It has one positive charge, so its atomic number is 1, and this gives the hydrogen the first spot in the periodic table. Its weight is 1 unit, so its mass number is 1. The second element is helium. It has 2 positive charge in its nucleus, but it has also 2 neutrons, so its atomic number is 2 and mass number is 4. In the nucleus of lithium, there are 3 protons and 3 neutrons, so its atomic number is 3 and mass number is 6.
Do you always get the same number of neutrons than that of protons?
Not at all. For example, the nucleus of gold, there are 79 protons and 107 neutrons. We are going to show you something else too.
So, and who are you?
Hydrogen.
Hydrogen. Hydrogen.
How is this possible?
The name of an element depends on the number of its protons. The 3 are all hydrogen because they all have 1 proton. But in total, they do not have the same number of particles, so their mass number are all different. They are called the isotopes of hydrogen.
Thank you for the explanations. Thank you for having been with us.
Oh, that's the way it is, and I will be here for a while.
The 20th century is called the atomic age. Was it simply innate human curiosity that pushed people to always make new discoveries? No. People are much more egocentric. They wanted to utilize what they had found. This can always be done in 2 ways. By constructing a machine to make their job easier, or by making weapons to get to power. In 1939, the nucleus split into two parts, and the world split into two parts correspondingly. The fire can burn, or give comfort and warmth. The wind can destroy, or propel a generator. The water can wash away, or power a mill. Let us tame nuclear energy too.
Sanctus